So in this lesson, we're going to be looking at quadratics, and specifically we're going to look at graphing a quadratic. So we're going to look at how you graph one in standard form and how you graph one in vertex form. And this is part of this standard where we're analyzing functions, and specifically we're looking at graphing polynomial functions. And the specific type we're going to be graphing is a quadratic function. So a quadratic function has two general formats, just kind of like linear equations. The standard form for a quadratic equation usually looks like this. A function is a number times x squared plus a number times bx plus c. So a, b, and c. So a is a coefficient of the quadratic term because it's what's squared. B is the coefficient of the linear term, and c is our constant. So the general shape of a quadratic kind of looks like a U, but we formally call it a parabola. So a quadratic equation, when graphed, will always form a parabola. So let's go ahead and do some graphing. We're going to just go ahead for these two, not worry about how I got them, but more worry about what they actually look like. Okay, so in standard form, when we graph them, this over here looks like that, and these are not accurate, by the way. We'll look at how to do them accurately again. The point that's going to be your maximum or your minimum point, or the lowest point or the highest point, is always called the vertex. And one thing you should note is when the coefficient of x squared is positive, it opens up, so I call those a happy parabola. And if a is negative, so that coefficient of x squared is negative, it's going to open down, so I call those sad parabolas. So that's what they look like. Okay. So one of the things that always has to be true is that when we have those parabolas graphed, and let me go back and add those in, they do have lines of symmetry. And the lines of symmetry, boy, that looks really ugly, huh? So when we go ahead and we have those parabolas graphed, one of the things we gotta know is they do have lines of symmetry that are always going to be right through the vertex. Okay, and it's called the axis of symmetry. The axis of symmetry is always going to be at y is at a vertical line. Vertical lines are always at x equals, and we're going to call it h. And the reason is because whenever we're talking about the vertex, we're always going to be using these two variables as our x and our y coordinates for our vertex. So x equals the x coordinate of the vertex. Okay, that turning point that divides the left side and the right side is called the vertex. And when the vertex is lowest point, like this one, it's called a minimum, but over here it's called a maximum. So this is a minimum, this is a max. Okay, so let's go ahead and look at how we can figure out the axis of symmetry and the vertex. So there's a little formula that you want to make sure that you know, and it's how to get the x coordinate. Fuck you. Come here. You're gonna go with me. No, I didn't want you. I'll be right back. So before we go on, we're going to learn a little formula that helps us figure out how to determine the vertex. So the vertex, when in standard form, is always going to be x equals the opposite of b over 2 times a. The y coordinate is always going to be f of x. So another way of thinking about it, this is what we call the h. And so we're doing f of the h to get the y. So that's going to give us our k value. And together, remember, H and K give us the vertex. Okay, so let's go ahead and use that. So first, is this going to have a minimum or a maximum? If A is positive, remember, it's going to be a happy parabola, which means it has a minimum. On number 2, if A is negative, it's going to be a sad parabola, which means it's going to have a maximum. Number 3, A is negative, maximum. And number 4, A is positive, which means it has a minimum. Okay, so I'm going to go ahead and do the work down here for number 1. So we have the x-coordinate is equal to the opposite of b, and in this case, I don't see anything, and that's because I'm adding 0x plus 0, which is why we only get 4x squared. So it's opposite of b, which is 0, over 2 times a, which gives me 0 over 8. 0 on the top is okay, which gives me 0. So now I'm going to do f of 0, and f of 0 would be 4 times 0 squared, which is 0. So the vertex is at 0, 0. And remember, the axis of symmetry is a vertical line through the x-coordinate of the vertex. And if you can find the vertex, usually everything else pretty much is easy to figure. Okay, let's go ahead and look at number 4. Okay, so on number 4, to get my x-coordinate, I'm going to do opposite of b, which b would be negative 8 over 2 times a. A is 1 because I don't see the coefficient in front of x squared. So that gives me 8 over 2, which is 4. So far I know my vertex is going through the point 4 something, and I also know my axis of symmetry has to be x equals 4. So remember, this is also the equation for finding the vertex. I mean the axis of symmetry, excuse me. Okay, so now I want to do f of 4. So I'm going to go ahead and 4 squared minus 8 times 4 plus 9. So that's 16 minus 32 plus 9, which gives me negative 16 plus 9, which is negative 7. Now let's go ahead and practice how we graph from standard form. So one of the first things we're going to do is find the axis of symmetry and vertex. Then we're going to go ahead and make a table of values. And when we do this table of values, we're going to go ahead and we're going to make sure that this is where our vertex goes. And then we're going to pick some numbers for x that are less than this x-coordinate of the vertex and some that are more. And we really can get away with just 3 points. 1 point has to be the vertex, and then another point would be to the left, another point to be or the right. You also could use some symmetry, and symmetry always is a good way to do it too. So let's practice. So here we are, and we're going to start with number 6. It's a little more complicated. So first thing we want to do is figure out what is our vertex. So to figure out our vertex, we're going to do our formula. X is the opposite of b, which would be 6, because the opposite of negative 6 is positive 6. A is 1, so over 2 times 1, which gives me 3. So what I know right now is my vertex has an x value of 3. So I know that when I go ahead and I plug in some other points, I'm going to pick 1 less and 1 more than 3 for my x's. So now to get the y-coordinate, I'm going to go ahead and do f of 3. So I'm going to do 3 squared minus 6 times 3 plus 11. So that's 9 minus 18 plus 11, which makes negative 9, plus 11, which is 2. So if I go ahead and I graph that on the coordinate plane, I know at 1, 2, 3, positive 2 is where my vertex is. I also know that there's a line of symmetry right there. And I don't always have to draw the line of symmetry, but I'll show you how we can use it. And then I also know, because A is positive, that this is going to be opening up, so my points should be above there. Okay, so now I'm going to go ahead and plug in 2. So when I plug in 2, I get 2 squared minus 6 times 2 plus 11. So that's 4 minus 12, which is negative 8. Negative 8 plus 11 is 3. So remember that line of symmetry we were talking about? So what should happen is, if I go ahead and I say, okay, I'm 1 away from the axis of symmetry to the left. So now if I go 1 to the right is where I should find a corresponding point. So if I go ahead and I plug in a 4, we'll see how that works out. So if I go 4 squared minus 6 times 4 plus 11, I get 16 minus 24, which is negative 8. And negative 8 plus 11 is 3. And there's that point, 4, 3. So if I go ahead and I plug in some more points, like 5 and 1 for my x's, then what I should get is, I should go ahead and I should get 6 for each of those. And so I go ahead and I'm going back to my graph. And so at 5, I'm at 3, 4, 5, 6. And over here, I'm at 6. And now I have enough to go ahead and sketch my parabola. And what's the domain of it? Well, I can pick any real number that I want. So the domain for every parabola that's a function is always going to be all real numbers. The range is always going to depend on the vertex. If it opens up, it's going to be numbers that are greater than or equal to the y-coordinate of the vertex. In this case, it would be 2. If it opens down, it's always going to be less than or equal to the y-coordinate of the vertex. Okay, let's go ahead and explore this one because it has a fraction and sometimes that's a little bit scary. So one of the things I notice is, just looking at it, is that this is negative and it's the coefficient of x squared, which means it's my a. So what does that tell you about the parabola? It tells you it's opening down. It's a sad parabola. So my a is negative 1/2. My b is the coefficient of x. And my c right now is 0 because I'm not adding or subtracting any constants. And so now I can go ahead and I can use my formula to find my x coordinate, my vertex. So I'm going to go opposite of b, opposite of negative 1, over 2 times a, which is negative 1/2. Well, I know that the opposite of negative 1 is 1, and positive times a negative in the denominator is negative, and half of 2 is 1, which gives me negative 1. So now I can go ahead and I can figure out a couple things. I know my axis of symmetry is going to be going through negative 1 on the x-axis. And now I got to figure out the y-coordinates to figure out exactly where the vertex is. So I have y is negative 1/2 times negative 1 squared minus negative 1. Okay, now in this case, I'm going to end up with a fraction, but that's okay. So I have negative 1 squared makes 1. Negative 1 half times 1 is negative 1 half. Minus a negative makes a plus, which gives me positive 1 half. You two have to be quiet. Okay, so if I go ahead and graph that, negative 1, positive 1 half, I get a point that's right about there. And then I'm going to go ahead and I'm going to use symmetry to find some other points. So I'm going to go ahead and do negative 2 and negative 3 for my x values. And I'm going to go ahead and plug those in. So if I go ahead and I plug in a negative 2, I get negative 1 half times negative 2 squared minus negative 2. Negative 2 squared is 4. Half of 4 is 2, which makes a negative 2. Minus a negative 2 makes a positive 2. And that makes 0. And knowing that these are each one to the left and one to the right of the vertex, I know that at negative 3 I also would have a 0. And now I have my parabola. And again, the domain is always all real numbers. And since this opens down, the range is always going to be less than or equal to the y-coordinate of the vertex. Okay, a couple of things to note is you always can figure out very easily the y-intercept of any function by plugging in the number 0 for x. So let's go ahead and we're going to look at the x or the y-intercepts, excuse me, of all of these. So the y-intercept, it's the value of y when x is 0. So if I plug in a 0 for that x and a 0 for that x, what I'm left with is 11. And if I go ahead and I go to this one down here, and I plug in a 0 for the x, I end up with a 5. So what do these numbers have in common? They're the c value. And so we basically are saying that c is always going to give us the y-intercept. Okay, so just like in a linear equation, we have a standard form and we have a slope-intercept form. Same thing is true with quadratics. We have standard form and then we have vertex form. So the vertex form of a quadratic looks like this. It says f of x equals a times x minus h squared plus k. So the number you're subtracting from x is always going to be your h. And the number that you're adding or stretching from the quadratic term is your k. And it's basically your vertex. H is the x-coordinate of the vertex, k is the y-coordinate of the vertex. The axis of symmetry is always going to be x equals h. And in this one, you can't tell what the y-intercept is going to be without plugging in a 0 for x. Okay, the a value, remember when we did transformations, tells us if it's reflected. So if a is negative, it's a sad parabola. If a is positive, it's a happy parabola. And it also tells us if there's a vertical stretch or compression. Okay, so the nice thing about vertex form is just like when we were doing those absolute value functions and looking at their transformations, it shows the transformations done to the parent function. And the parent function of a quadratic is just y equals x squared. What is wrong with you? Stay right there. Okay, so let's go ahead and we're going to describe the transformations. So what is this? If the parent function, remember, is just x squared, and we have plus 9, that means it's outside of what's being squared, and we're adding something, which means it's going to go up 9. This would mean we're going to go down 2. Now this one, the plus 5 is inside. So remember when we talked about transformations, that number that you're adding is stretching inside where the x is always does the opposite. It's a shift left. So it's going to go left 5, and a is negative, which means it's going to reflect. So it's sad. Okay, minus 4 in there with the x that's being squared means it's going to go to the right. 4, and that minus 1 means down 1. Okay, 1/3 x squared means we have a vertical compression. I'm going to abbreviate. And that plus 2 means we went up 2. That negative 2 means reflect and stretch. And that plus 4 means go left 4. Okay, now let's actually go ahead and use this. So what I'm going to do before we go on is just think about the parent function and what the table of values for the parent function would look like. So for a parent function, the vertex is normally going to be at 0, 0. Remember, we're looking at y equals x squared. If I negative 1, I get a 1 as well. If I plug in a 2, I get a 4. And if I plug in a negative 2, I get a 4 as well. So what we're doing is we're just moving each of these points. So first figure out where your vertex is. Remember, it's what am I subtracting from the x? 2. And then what am I adding or subtracting to the quadratic? 3. So my vertex is going to be at 2, 3. So 2, 1, 2, 3. Sorry, the puppies. And now I know that all my other points are kind of be in their normal position. So 1, notice that the points to the left and to the right, like the first integral points to the left and the right, are just 1 unit up. So if I go 1 over and 1 up, I get 1, 4. And if I go, sorry, said that wrong, I get 3, 4. And if I go ahead and use symmetry, I am at 1, 4. It's a really crappy graph. Okay, through a little magic, I made it a little bit bigger. Okay, so there's 2, 3. There's 3, 4. And there is 1, 4. And now I could go ahead and remember from that parent function, we had 0, 0, negative 1, 1, 1, 1, 2, 4, and negative 2, 4. Okay, so now look at the distances between these y's. That's a distance of 1, and these have a distance of 3. So these are my distance of 1, and so that means this one has to be 3 higher at 7. Following the pattern for the x's, I have 0. 1, 2, 3, 4. Distance is 1, distance is 3. So if I go 4 plus 3, I get 7. 2, 3, 4, 4, 5, 6, 7. 0, 4, 5, 6, 7. And it says that when a is equal to 1, that as I move 1 unit to the right of the vertex, that the distances are always going to be vertically between the subsequent points is always going to be 1. So there's my distance of 1. Then 3. And so if I went ahead and I did the next one, it would be at a distance of 5. Usually I'm not going to go that far out. And we'll practice that again. Okay, so let's go ahead and on this one, let's look at how that 1, 3, 5 rule works again. So this is a shortcut for graphing and it helps especially when you're in vertex form, so you don't have to do a lot of arithmetic. Okay, so first step is find the vertex. So my vertex, what am I subtracting from x? Well, remember to make a plus, it's a minus. So it would be negative 5. And then, am I adding or subtracting from the quadratic? Negative 1. Which way does my vertex go? Well, it's going opening down. So that means I'm going to be going negative 1, negative 3, negative 5 when I graph those other points. Okay, so I know my vertex is at negative 1. So now I'm going to go, just with my x's, I'm going to go 1, negative 6, oops, sorry. Negative 6, negative 7, negative 4, negative 3. So that this one is going to be 1 unit away. Remember, since I'm going down, it's going to be 1 unit down, negative 2. Then this one is going to be 3 units away from that. And again, I'm going down because of the reflection, negative 5. So now I'm using symmetry. Negative 6 should be at negative 2. And negative 7 should be at negative 5. And we can verify that algebraically, and we will. Okay, so first I'm going to go ahead and graph my vertex. Negative 1, 2, 3, 4, 5, negative 1. And then I'm at -4, -2, -3, -5. Using symmetry. Didn't quite get to -5, did I? Two, three, four, 5. There we go. And now I go ahead and I do my graph by connecting those coordinates. Okay, let's double check to see if we were right. So if I do f of -3, I expect that I should get -5. So I'm going to do the opposite of -3 plus 5 squared minus 1. Well, -3 plus 5 is 2. 2 squared is 4. So I get -4 minus 1, which is indeed -5. Now let's look at one that also has a stretch or a compression. So we're going to look at number 11. So when I'm looking at this one, again, we start off by finding the vertex. So the vertex is going to be at, what am I subtracting from x, which is 4. What am I adding to the quadratic? Nothing. So the vertex is at 4, 0. Okay, now this time, what's going to happen is, because it's a vertical stretch, when I use that 1, 3, 5 rule, I'm going to be multiplying by 3 each of these numbers. So that means I'm going to go 3 away, 9 away, and 15. If a was a fraction, I would multiply by the fraction. Okay, but my x coordinates, I'm going to be using still 5, because 4 plus 1 is 5, and 5 plus 1 is 6. Then I'm going to subtract 3 and 2, and that's how I'm getting my x values. So now, this point, vertically, it's going to be 3 units away from 0. So now I'm going to go ahead and do 0 plus 3, and then this one, vertically, is going to be 9 units away. So I'm going to go ahead and add 3 plus 9, which is 12. Going the other way, it's going to be 3 and 12 also because of symmetry. Okay, so now we go ahead and we graph 4, 0. 1, 2, 3, 4, 0. And then we're going to go ahead and we're at 5, 1, 2, 3. And then we're at 3, 3. And then we also have 12, which is going to be off of my parabola. So I'm just going to go ahead and, so when it's a vertical stretch, it's a very skinny parabola. And let's double check our math. So if I go ahead and I say, what is f of 5? I get 3 times 1 squared is 1. 3 times 1 is 3, which is exactly what we started with. Okay, thanks.